So the next concept that I want to help you with is the concept of end behavior. And as you can see here, the question, what functions have the same end behavior as this given function here? So here's the mindset that I want you to have. When you look at this function, I want you to be thinking. So I want you to think, okay, this is a second degree polynomial. So when it's in standard form, it's the highest power. The a, the leading coefficient, is equal to 1, and that's positive. So we have an even degree, and we have a positive. So even degree a positive, we know that as x goes to positive infinity, y goes up no matter what side you go to, bottom line. That's the end behavior model. And then if you remember, we discussed a chart. Actually, we called it a Punnett Square. That's what it is. So we have a Punnett Square, and we have a being positive, and we have a being negative, and we have the degree of the polynomial being even, or the degree of the polynomial being odd. And so this is kind of like the biggest thing that about end behavior. So when we're dealing with end behavior, it's good to know when x gets big in the negative or the positive direction, what is the graph going to look like. And so we know that it's going to look like that. A is positive, the degree is even, so we could have multiple bumps. And then if a is negative and degree is even, the ends of the graph go in the same direction. A is positive, degree is odd. It could go just up from left to right. Could be a straight line. Could have a bunch of bumps. As long as the end of the graph goes up when you're going to the right, and the graph goes down when you go to the left. And then same with a negative. So the graph goes down from left to right. So when a is positive, the graph goes up when you go to the right. And when a is negative, the graph goes down when you go to the right. So there's a lot of similarities here, but these are the 4 possible combinations. And so when you think about that kind of a thing, what functions have the same end behavior as this function here? Let me erase some of this stuff here. So when you're thinking is the degree, and you want to be thinking about, I'll leave that on there. So if we look at a couple functions here, would this one have, so y equals 4x to the 6th minus 3x plus 1. Would that have the same end behavior as the given f of x? And so, again, you're thinking to yourself, what's the degree? And what's the a? The a is positive. So if we have a positive and the even degree, then this function right here would have the same exact end behavior as this function. So the end behavior of this model is like that. The end behavior of this model is the same thing. So yes, check. That would have the same end behavior as the original function. How about another one? Let me erase some of this stuff. Let's try this. What's the next one? All you got to be thinking is that same thing. So how about this? G of x equals 4x squared minus 3x to the 4th. Okay, so then I want you to pause the video and ask yourself, does this function have the same end behavior as the given function? So here's the answer. The degree is so the degree is determined by the highest power when it's in standard form. Well, it's not even in standard form. Standard form is negative 3x to the 4th plus 4x squared. And so this is standard form. Highest power, the next highest, and so on. So the highest power is 4, so the degree is 4. And the a value is negative 3, and that is less than 0. So if a is less than 0, now we're over here, and the degree is even, so the graph would look like that. And that's not the same end behavior as this one. So no, This one would not have the same end behavior. You always have to put the function in standard form to determine if the given function has the same end behavior as the one listed. So let's try it again. Try another one. Actually, we'll do another video for a couple more examples.